A stunning divulgence by the James Webb Space Telescope has gotten the consideration of spread-out researchers humming. Confounding lights, apparently looking like cityscapes, have been tracked down in space around 7 trillion miles from Earth. These odd lights emanate from the exoplanet Proxima Centauri b, the nearest known exoplanet to Earth, filling hypotheses about the chance of extraterrestrial life. The telescope's zero-in on Proxima Centauri b uncovered these dazzling lights, raising the issue of whether they could flag the presence of a human progress. Join us as we analyze how the James Webb Space Telescope has seen these phenomenal qualities and what they could mean for how we might interpret life beyond Earth. For a really long time, subject matter experts and everybody the same have anxiously expected any sprinkle of life outside our planetary framework, and this new divulgence has sent shockwaves through standard science. The James Webb Space Telescope, while planning the universe and sending pressing data back to Earth, apparent odd lights that seem to enlighten a far-off city on Proxima Centauri b. The coherent presence of an outsider city on this close-by exoplanet has left researchers both confounded and energized, as it could address the very proof of shrewd life they have been looking for. On the off chance that these lights are for sure what they appear, it would propose that there are advanced, human-like civilizations in space that are just now being seen by humankind. As NASA specialists peer into these distant city-like lights, they can't help but think about how long they have been sparkling in space, trusting that individuals will develop the innovation expected to distinguish them. David, a cosmologist from Columbia College, depicted Proxima Centauri b as an especially interesting planet to study because of its exceptional warming examples, which vary fundamentally from those of other rough planets. Not at all like normal planets that retain daylight and produce infrared radiation, Proxima Centauri b shows an infrared mark that is particular from its star, making it an optimal concentration for the James Webb Space Telescope. The telescope's capacity to see infrared frequencies has made it the ideal apparatus for observing Proxima Centauri b's warm emanations and uncovering privileged insights about its climate. Experts are as of now utilizing the James Webb Space Telescope to further research the secrets of Proxima Centauri b, with an accentuation on its ecological parts and the potential for habitability. The telescope's infrared awareness permits it to investigate what occurs on the planet's night side, catching even the slightest light outflows in the tremendous infinite dimness. This capacity is pivotal for checking whether the claimed city lights on Proxima Centauri b are legitimate. Each weak light in the universe can be identified by the telescope as long as it falls within a specific recurrence range, making the James Webb Space Telescope a critical instrument in the quest for extraterrestrial life. Proxima Centauri b has an interesting association between its glorious qualities and surface circumstances. The exoplanet encounters steady cycles like those on Earth, with its day side engrossing daylight and its night side cooling quickly. The temperature minor departure on Proxima Centauri b, impacted by its barometrical structure, gives a convincing subject for additional review. Assuming the planet misses the mark on environment, the temperature distinction between day and night would be outrageous, while a climate would direct these varieties. The James Webb Space Telescope, with its unrivaled infrared imaging capacities, is appropriate to look at these warm emanations and provide insights into the planet's environmental properties. Outstandingly, the orbit of the James Webb Space Telescope around Earth lines up with Proxima Centauri b's orbital period, taking into account non-stop perceptions of its day-in and day-out cycle within 11.2 Earth days. If Proxima Centauri b does indeed have an atmosphere, the subsequent stage will be to assess its substance piece to decide whether it could uphold life. Markers, for example, oxygen, water vapor, and methane would propose that the planet has habitable circumstances. However, distinguishing these parts requires careful examination of light passing through the planet's atmosphere, a challenging task in any event, for a telescope as progressed as the James Webb. While the James Webb Space Telescope has its impediments, especially in distinguishing supported oxygen, a crucial marker of life, it remains an important asset for concentrating on the ecological condition of far-off exoplanets. Researchers are likewise expecting future ground-based observatories, for example, the Extremely Large Telescope, ELT, set to start activities in 2028. The ELT will provide further bits of knowledge into the climatic examples of far-off exoplanets, improving the revelations made by the James Webb Space Telescope. Regardless of its current constraints, the James Webb Space Telescope continues to play a huge role in our mission to uncover the secrets of far-off exoplanets. Its capacity to dissect the slightest hints of light from faraway planets considers a reasonable assessment of their environments and the potential for life. This undertaking, however, accompanies its own challenges, as experts must recognize gases delivered by natural cycles and those produced by geographical activity, for example, volcanic emissions. The James Webb Space Telescope addresses the front of logical headway in the examination of exoplanets. Its perceptions offer a brief look into the amazing disclosures that lie ahead as we push the limits of how we might interpret the universe. As we explore further into space, the telescope will continue to provide important data on far-off worlds, helping us unwind the secrets of these distant planets. Quite a while back, the space past our nearby planetary group was generally ignored. From that point forward, space experts have recognized more than 4,000 exoplanets circling far-off stars, displaying the degree of human interest. Yet, NASA sees these disclosures as the tip of the iceberg, with trillions of exoplanets as yet anticipating investigation. Researchers are determined to research these obscure universes in order to find extraterrestrial conditions where humans have never wandered. Over the years, there have been glimmers of hope in the quest for extraterrestrial life. For instance, when the Galileo rocket visited Jupiter, its spectroscopic instrument recognized a surprising unearthly mark, proposing the presence of extraterrestrial vegetation, the first biosignature demonstrating life in the universe. This biosignature, known as the vegetation red edge, VRE, reflects light in a manner that could uncover the presence of outsider life. The James Webb Space Telescope, furnished with VRE abilities, is supposed to divulge the secrets of extraterrestrial conditions by planning the orbital attributes of possibly tenable planets within their stars' livable zones. Once recognized, the VRE could provide significant proof in the hunt for intelligent life beyond Earth. As daylight goes through a planet's atmosphere, the light is consumed by particles and molecules, creating a particular unearthly example that can be investigated through spectroscopy. This example serves as a unique fingerprint, permitting scientists to translate the barometrical piece of far-off planets. It is conjectured that the James Webb Space Telescope could identify light as it enters a planet's atmosphere, providing insights into the planet's barometrical cosmetics. Earth-sized planets with climates wealthy in carbon dioxide, nitrogen, and oxygen might actually support life. However, the shortfall of startling mixtures could show elective types of life or advanced civilizations, such as chlorofluorocarbons, CFCs, which are engineered and utilized for refrigeration. Modern purposes could act as marks of extraterrestrial turns of events. If the James Webb Space Telescope were to recognize these mixtures on another planet, it could give strong evidence of outsider life. In spite of the telescope's current limits in recognizing certain parts, it stays a fundamental instrument for contemplating exoplanets and propelling comprehension. We might interpret the universe. Researchers expect to decrease the splendor of a star's light, having better perception of weak light reflected from the actual planet. They plan to accomplish this by utilizing inside veils or huge outside satellites, similar to using an umbrella to shut out daylight. Future telescopes will actually want to zero in on the weak marks of light from far-off exoplanets more effectively, prompting a more clear appraisal of their airs and their capability to support life. This move toward will help space experts separate between gases delivered by life and those produced by topographical processes. Even as specialists work to refine their techniques for contemplating exoplanets, they continue to investigate the universe looking for indications of something going on under the surface. The James Webb Space Telescope, with its unequaled capacities, offers an impression into the eventual fate of space investigation and the potential disclosures that seek us. As we keep on expanding the constraints of our insight, we are more ready to comprehend the intricate operations of the universe and our place within it. Regardless of many years of looking through, researchers have yet to track down authoritative proof of life past Earth. In any case, the mission continues, driven by humankind's persevering through interest in whether we are alone in the universe. For quite a long time, individuals have contemplated whether they are the only canny creatures in presence, an inquiry that remains unanswered to this day. The James Webb Space Telescope is only one of many instruments being utilized to look for extraterrestrial intelligence, as researchers study a wide assortment of planetary bodies for indications of life. Well-known hypotheses propose that extraterrestrials may without a doubt be out there, just sitting tight for humankind to find them. To answer this call, the SCI, Search for Extraterrestrial Intelligence, Foundation, laid out in 1984, spotlights on filtering immense transmissions, especially radio transmissions, which can travel significant distances without being dissipated or absorbed, making them bound to be identified. The 42 radio telescopes of the Allen Telescope Array in California's Sierra Nevada have been checking these signs for more than 30 years. All things considered, no persuading proof of extraterrestrial life has been found. In any case, Jill Tarter remains confident, expressing certainty that the instruments of the 21st century will speed up the hunt. She urges individuals everywhere to become dynamic members in the definitive mission for vast friends. This journey continues until recent reports from NASA suggested that the James Webb Space Telescope had identified city-like lights on a nearby planet. The telescope, considered humankind's most advanced instrument for investigating the universe, is now circling around 1 million miles from Earth, sending back data that researchers hope will reveal whether intelligent life exists on different planets. Cosmologists use spectrometers to dissect light emitted by exoplanets and their host stars, permitting them to gather fundamental information about the planet's atmospheres and assess their potential for livability. The James Webb Space Telescope can gauge infrared light frequencies and identify gases fundamental for life, like water vapor, oxygen, methane, and carbon dioxide. By examining the light patterns of these gases, researchers can gain critical insights into a planet's capacity to support life. While the James Webb Space Telescope has its constraints in recognizing specific parts, such as oxygen, it remains a critical instrument for exoplanet investigation. The telescope's capacity to dissect light in the infrared range empowers specialists to determine the synthetic composition of a planet's atmosphere and assess its life-supporting potential. Regardless of the challenges that continue to face the quest for extraterrestrial life, the James Webb Space Telescope marks a significant forward-moving step in our understanding of the universe and our place within it. As researchers proceed to break down the data sent back by the telescope, they remain hopeful that one day they will find conclusive evidence of life beyond Earth. The James Webb Space Telescope has made a critical discovery that has astonished both researchers and the public. Odd lights that appear to resemble those of a city have been identified on Proxima Centauri b, an exoplanet circling the nearest star to our solar system, found roughly 4.24 light-years from Earth. Proxima Centauri b has been a subject of great investigation since its discovery, mainly due to its proximity and its potential to harbor life. The lights, which appear to illuminate portions of the planet's surface, have prompted speculation that they could be of artificial origin, perhaps the result of a high-level extraterrestrial civilization. The JWST, with its remarkable capacity to capture infrared light, has been instrumental in observing Proxima Centauri b more meticulously than ever before. The telescope's advanced sensors have detected these bizarre light patterns during its survey of exoplanets within our vast universe. These observations have ignited excitement and interest among astronomers, who are now delving deeper into the data to understand the nature and source of these lights. Proxima Centauri b orbits within the habitable zone of its star, Proxima Centauri, meaning it could have conditions suitable for liquid water, a vital component for life as we know it. This makes the discovery of potential artificial lights even more intriguing, as it raises the possibility that life on this planet might have evolved to a point where it can produce large-scale lights, like human cities on Earth. If these lights are indeed artificial, they could represent a civilization that is either contemporaneous with humankind or potentially far more advanced. The identification of these lights was made possible by the JWST's complex instruments, which can detect faint infrared emissions that other telescopes might miss. Infrared light, which is emitted by warm objects, can penetrate dust clouds and reveal details that are typically hidden from view. This capability has allowed the JWST to observe Proxima Centauri B's night side, where these lights were identified. It is not only suggested that they are reflections of starlight but possibly something significantly more exceptional. One of the main challenges in confirming the nature of these lights is distinguishing between natural and artificial sources. Natural explanations could include volcanic activity, bioluminescent life forms, or even reflections from the planet's surface. However, the intensity and consistency of the lights observed by the JWST seem to stand apart from ordinary natural phenomena, prompting researchers to consider an artificial origin. Consequently, astronomers are conducting follow-up observations using both the JWST and ground-based telescopes. These observations aim to gather more data on the light emissions, including their spectrum, which could provide clues about their composition. By analyzing the spectrum, researchers hope to determine whether the lights are produced by gases in the planet's atmosphere, surface materials, or artificial structures emitting light, like cities on Earth. The implications of finding an extraterrestrial civilization on Proxima Centauri b would be enormous, not only for our understanding of life in the universe but also for humankind's place within it. Such a discovery would challenge our assumptions about the uniqueness of intelligent life and could potentially lead to a new era of interstellar communication or exploration. All things considered, researchers remain cautious, as extraordinary claims require extraordinary evidence.